Welcome to my channel. I'm Zhang Xu. Let's look at the problem 25 in chapter 11. Chapter 11 is about rotational momentum. And this one in this system, we can see we have a particle, and we know it is located about a fixed axis, and then we need to prove the tangential radical vector component of linear acceleration satisfies these two equations. So how can we do that? First of all, we can see the particle is there, right? And it does a circular motion around this axis. And the distance from the origin to the location of the particle is r. And then we can see, first one, we consider the linear velocity for this particle is v, right? And then can we find the relationship between omega and v? Sure, because it rotates around this rotation axis, so omega is up in this direction. Alpha angular acceleration is up, right? So now we need to find the radius for this rotation. You can say this is r, so this length, this is theta, so this length is r sine theta. Agree? So that makes the linear velocity v equal to omega times this radius r sine theta. There, this r is not radius. This r is a distance from this origin to this location, the particle's location. Agree? Yes. Now we first find the acceleration and tangent direction. Acceleration and tangent direction. This is a linear acceleration, right? So we use dv dt, right? dv dt derivation v with t. This is we learned in chapter 3. Now input is a v inside. Input is a v inside. If I look like this one, so we can see this r will never change. This r is the location from the distance from the origin to the location, no change. And then we solve this equation, we find the angle theta will not change, right? So we only change is omega. So d omega dt is what? Is alpha. Alpha is the angular acceleration. So we get this equation. Now we look at the general equation there. It tells us the cross product a cross b equal to ab sine theta. Now you can see there, the acceleration tangent equal to alpha r sine theta, right? So we can write it in this way. Just compare with this one. Agree? So the first one is proved. Now we look at the second one. The second one we need to find the central acceleration. Central acceleration we learned in previous. Central acceleration is v squared divided by radius. The radius is r sine theta, right? Then how can we do that? We have a small trick. We split this v squared as v times v. Agree? V times v. And then look at this term, what it is. It is just omega. So in this one, we use v divided by r sine theta, just omega. So we replace this term with omega, right? Now, can you find the angle between v and omega? Sure. V and omega is perpendicular because v is at this xy plane, and omega is up, right? So that this is 90 degrees. So we have so you can consider it times sine 90 degrees. Sine 90 degrees is 1, so we can ignore it. And then still we find the AR equals V omega sine 90 degrees. The angle between them is just 90 degrees, and then we still consider this equation. We find A alpha is omega cross V. Thank you.